Today we will discuss about the acid catalyzed aldol condensation. Previously we have discussed details about the aldol condensation, and all whatever we have discussed, it is about the base catalyzed aldol condensation. Base catalyzed aldol condensation is widely known, but also there is a type of aldol condensation which is basically controlled by the acid only. Okay, so let's start acid catalyzed aldol condensation. So for instance, take an example of cyclopentanone. 1 2 3 4 5 cyclopentanone. Now suppose I am using small amount of dilute HCl. Now how many lone pairs? Two lone pairs over oxygen. Now it will be protonated. So what will be the structure? You see the structure. Okay, now it is protonated. Now there is one alpha hydrogen. This will abstracted by the chlorine ion and it will undergo resonance. The structure will be okay. Now what will happen? It will undergo resonance with the second molecule of cyclopentanone. What will happen? Now the molecule will be okay. Here the formal positive charge will be there. Now it can accept the proton. We have dilute HCl in the medium. So this proton will again protonated. Sorry, this oxygen is again protonated to form the hydronium ion. We will write the molecule. Now it will gain formal positive charge. Here again there is alpha hydrogen. Now this alpha hydrogen will abstracted by chlorine ion and the structure will be formed like this. This is the product formed in the acid catalyzed reaction. You see here, this is the carbonyl group and this is alcohol group. Okay, here also there is availability of lone pair over oxygen. Here also oxygen. So but this oxygen is protonated. Why not this oxygen? Because if we will state the hybridations of these two oxygen, here it is 1 2 3 sp2 and it is 1 2 3 4 sp3. So the electron withdrawing capacity of this oxygen is more than this. That means these lone pairs are more tightly held by this oxygen. than this. So we can say in other way, that means these lone pairs are more available for protonations than this lone pair over this sp2 hybridized oxygens. That's why when we compare these two oxygens, protonation is more favorable in the sp3 oxygen rather than sp2. Okay, this one confusion may come to our mind, though both oxygens having lone pairs are available. Why one is protonated rather than other? So this is one of the explanations. Okay, so this is all about the acid catalyzed aldol condensation.